All right, so today we focus on physics. And as usual, we're going to find a few questions on light. So our target for today is to do 3 questions. And then you have to go through these questions once I send you the video. So we're going to do one question on light. We're going to do another question on transformers. And the last question that we're going to do will be on electricity. So again, I'm going to just explain a few principles and things are going to be clear that way. So let's begin. So let's look at question B6. Question B6 is a ray diagram, meaning you have to carry at least a ruler and a pencil in case you make a mistake. So the principle in the exam is that when you're drawing any form of diagram on a graph paper, you have to use at least a standard HB pencil. So here is an object that is placed on a thin converging lens. So because it's a converging lens, we expect the ray diagrams to intersect at some point. If they don't intersect, we have to make them intersect backwards, meaning the image that will be formed will be a virtual image. But once they intersect, it means it's a real image that has been formed. So one way or another, because it's a converging lens, the ray arrows have to converge at some point. And depending on where the rays converge, we can either form a real image or a virtual image. So the question continues and says, complete the ray diagram to locate the position of the image formed by the converging lens. So we have to look at this diagram critically. We can see that this object here has been placed between focal points 2. So here is a focal point where an object can be placed. The distance from this principal axis here. So from the distance from there to there, that's the first focal point. And this is focal point 2 or 2F. So we have to take note of the 2 focal points there. So we have to construct 2 rays. The first ray has to be parallel to this principal axis here. Sorry, the principal axis is this horizontal line. So the first ray from the object is always parallel to the principal axis. So we can draw that first ray of light. Always it has to be parallel to the principal axis. So the first ray is going to come from this point there, and it's going to hit this line here, this vertical line, like so. And then, of course, it has to go somewhere. So it has to pass through the first focal point. So you draw another line and extend it, making sure it passes neatly through this focal point 1 there, like so. So that would be your first ray. Remember, the first one has to go directly through the principal axis. Then it has to pass through focal point 1. However, this one, because we always need a ray that will be parallel to the principal axis. But the second ray here, if the image was placed at focal point 1, the ray would have just gone directly across here. However, this object has been placed at focal point 2, meaning the ray has to pass through this first focal point there before it goes to converge to another ray. Whether it will converge or not, we are yet to determine that. So you draw neatly another line that will extend from there, passing directly through this first focal point and hitting this principal axis there. You just make it a bit neat. Yeah, okay. So this line has to pass straight through this focal point there, and it has to hit this point there. Again, if the object was placed at this first focal point, this line would have passed through this line like that. but there's a focal point here. There's focal point 1, focal point 2. So we have to pass through this ray uh, on this focal point 1 until it hits this converging lens here. You know, this vertical line represents a converging lens. Then your next arrow from here, from the lens, it will be again parallel to the principal axis. The principal axis, again, it's like this x-axis, this horizontal line there. So I'm going to draw another ray which is directly parallel to the principal axis, like so. So where these two lines converge here, that's where the object is going to be formed. So the object will be formed. My diagram isn't that accurate, but the lines seem to converge here, actually. Because now we are drawing an image, the image of an object. So let's use an arrow. So they converge somewhere. They converge somewhere. This virtual learning. They converge somewhere there. Okay, something like that. So this right here that we've drawn is the image of the image of the object. So the image of the object is right there. And as you can see that this image that has been formed, it's actually inverted. It appears on the opposite side. It's every inverted image. The fact that it's inverted, it means it's real. So every image that has been formed that's upside down, it will be inverted, real, on the other side of the lens. So other side of the lens. And if you were to, you know, if you're in an exam, you can actually, you have to measure the height of the object, and the image that has been formed. And if you can see, they are actually the same size. If we were in an exam setting and you get a rule and you measure the distance from there to there and there to there, you will find that the image formed is, so image is same size as the object. So these are the characteristics of this image that has been formed. And the rule of thumb, all objects that are placed directly at 2F. So there are actually 3 scenarios. You can place an object at F. There will be a characteristics of the image that will be formed. You can place an image at 2F, and you can place an image beyond 2F, and just before the lens. You can either place the image there, or at F, or at 2F, or beyond 2F. And all those images formed, they have their own characteristics. So if you have like a physics textbook, or you nowadays you don't even need a textbook. You just go to the internet and you type in on Google, what are the characteristics of the image formed when it's placed before F, at 2F, and beyond 2F, so that you actually see all the ray diagrams that you're supposed to draw and the types of images that have been formed. But even with that knowledge, just by drawing your ray diagram and measuring the height of the image formed, you can determine all the characteristics of this image, that just like we've just done. So the image has been formed there. It's inverted, meaning it's real. It appears on the opposite side of the lens, and it's the same size as the object. So state the characteristics of this image. So that's your answer there. It's real, it's inverted, it's real, same size as the object. You just write what we just discussed there, and it appears on the opposite side of the lens. So now here, there's a formula for magnification that you're supposed to know. By the way, again, I told you physics is all about formulas. So you have to be able to, when we learn a new formula, just write it down there, go through the video, try to practice a bit. So there's this formula here which states that magnification is equal to the height of image, divided by the height of object. Any normal examiner will give you a mark for stating the formula. And because in our case, if you were in the exam and you get a ruler, you will find that the image and the object size are exactly the same. So let's assume you got your ruler and you measure your object height, the distance from there to there, and you measure your image height, the distance from there to there, and you discover that your object is 2 centimeters and your image is actually 2 centimeters. Therefore, your magnification will be 2 centimeters divided by 2 centimeters. Magnification has no units. 2 in there, 1, 2 in there, 1. So your magnification will be times 1. So don't forget to put this times 1 because it shows by what factor have you magnified your object. So here we haven't magnified the object at all because the image that has been formed is actually the same size as the object. So this is how you handle ray diagrams. I actually find them very easy. It's just that, there's this sort of timid nature where students go into an exam and they just say, wow, physics, I can't do this. Look at this complicated ray diagram. They start drawing weird things. You just have to know the principle. You just have to know how to apply the principle. Then things are going to become easy. So remember, as a form of summary, the first ray that you have to draw, this is the principal axis here, the horizontal line. So on the object itself, the first ray of light that you have to draw has to be directly parallel to the principal axis, and it has to hit your converging lens and pass through the first focal point, like so. Then your second ray will either pass directly across the lens if it was placed at focal point 1 there, or just before the lens. But here we've skipped a focal point 1, focal point 2 there, 2F. So the second ray has to pass through this focal point. We just can't draw a diagram directly across. We have to take into account this as the first focal point there. So it will pass through the first focal point, it hits that part, then it will go directly parallel to the principal axis and they'll converge. So the image is going to be formed there. Every image that is inverted is a real image. It appears on the other side of the lens. And at times it can be the same size. So the images that you are going to encounter will either be the same size as the object. Anyway, they can either be real or virtual. They can either be inverted if they are real, upright if they are virtual. They can also either be the same size as the object. They can either be the same size as the object, like we saw here with the real image, same size as objects. If they are virtual, they will be magnified. Actually, you can use enlarged. They'll be enlarged or magnified. At times, the image formed can also be diminished, depending on where you place your focal point. So don't just memorize these ray diagrams. You can actually do this practically. If a question comes and they say, draw a ray diagram, just carefully draw it, following these principles that we've discussed. I hope this makes calculations with light, or how to draw ray diagrams and calculate magnification just a little bit more bearable. Are we together? We're together?
Yes.
All right, thank you. Okay, so let's first read this intimidating question, then I'll make it very easy for you to understand. So we have a step-up transformer, increases its voltage. So let me just read it passively before I highlight it and I explain a few things. So I've got a step-up transformer, and it increases the voltage of an AC supply from 110 volts to 220 volts. The primary coil dissipates a power of 101 kilowatts. So every time you see something like kilowatts, it means there will be an element of power, and you have to use the equation power is voltage times current. And the transformer has an efficiency of 100%. Interesting. If the number of turns in the primary coil is 400, how many turns are in the secondary coil? So when it comes to transformers, we have got two types of transformers. You can either have a step up transformer or a step down transformer. So we have to understand what is the nature of a transformer. So a transformer, you underline it. You can write down these notes when you get the video. So a transformer is a device used to vary the voltage. A transformer is a device that is used to vary the voltage of an AC power supply. So not a DC power supply, but an AC power supply. Because you know, we receive power into our households in these electrical lines, and there is usually a transformer there theoretically, and this is a house, and power goes into the house. So this is the power supply. So power literally moves at ridiculously high voltages that are not safe for households, generated at the power plant there. So as power is traveling through these electrical power lines, it's at an extremely high voltage, meaning for the power to be received in the house safely, you have to step down. You have to vary the voltage in such a way that it's actually safe for a household. So you are going to put a step down transformer there, a step down transformer, so that the voltage that is reaching this household should be safe. However, there are times where you have an industry. So maybe this is like an industry, maybe a mine. And you know, mines need actually a lot of power to, you know, carry out all their work activities. So what we're going to have here is a step up transformer, so that you can actually increase the voltage that's being delivered to this massive electricity usage industry. So there are two types of transformers, one for the household, so that the neighborhood shouldn't have an overload of power to protect your electrical appliances and also your lives from electric shock. And a step-up transformer that actually increases the voltage so that industries can actually have that high voltage that they need. So how does a transformer work? So a transformer will actually work on the principles of electromagnetism. You remember that diagram in grade 9, like a solenoid. If you know what a solenoid is, a coil with a current carrying wire, you can actually generate a lot of current. So a transformer is going to look like this. It's just a cylinder. So a question can actually come in this way where it's just a string of texts where you have to read, or they'll draw a diagram for you. So they might draw a diagram, something that looks like this, like a rectangle within a rectangle within a rectangle. And here, there will be coils, and there will be a voltage supply there, a switch. And also here, there will be coils with a voltage supply there. So this first coil here is known as the primary coil. Primary coil. And this coil here, a coil is this rounded thing. And this coil here will be called the secondary coil. So the more coils, the greater the current is going to, or the greater the voltage is going to be. So because this is actually a complete circuit, there will be a current there. So this is current, capital letter I for current. And because this is the primary coil, we're going to say current in the primary coil. And there's a voltage here. So we're going to say voltage in the primary coil. And this here, this is a complete circuit with current flowing through it. So I'm going to say this is current, the secondary coil, and there's a voltage there. So I'm going to say voltage in the secondary coil. So what's going to happen here, the more coils, the more power is going to be generated. So here, if we complete the circuit here, there will be a current that's going to pass through both in the primary and the secondary coil. Because there are more coils there, there'll be a very strong electromagnetic force here, meaning more current is going to be produced. It's like you're making this strong electromagnet. So if you have more coils there, so the more coils, the more voltage. The more coils, the more voltage. So this is the characteristic of a step-up transformer. So this current here is going to be transmitted, and a huge voltage is going to be generated in the secondary coil, hence supplying more power to industries. But if you want to step it down, you reverse it. So you have to just decrease the number of coils. So you actually reverse it like so. So I'll just draw a simple diagram just indicating the coils. So if you want it to be a step-down transformer, your primary coil is going to have more turns, and your secondary coil is just going to have less turns, so that the voltage that's being delivered there will be low. So the higher the number of turns, the more voltage that's going to be delivered either at a household or at an industry. So that's how transformers work. And every transformer that's at 100% efficiency, and they are not going to change this question. At your level, they'll use this 100% efficiency, obeys this formula and this relationship. Voltage in the secondary coil over voltage in the primary coil is equal to number of turns in the secondary coil over number of turns in the primary coil is equal to current in the primary coil over current in the secondary coil. So unfortunately, you just have to know this formula, write it down somewhere, meditate on it. It's very easy. It's just voltage, number of turns, current, voltage in the secondary coil. So at least this part is the same. There is a SSPP. Then you just invert the next one for current. You just say, okay, the P is above, the S is below. So it will be current in the primary coil over current in the secondary coil. So it's more or less like sine. So I can either isolate this part and work out the problem alone, or I can isolate this part and work out the problem on its own. So let's now go back to the question and try to answer the question in a step-by-step manner. So we read through the question now with having the knowledge that we've been equipped with. So a step-up transformer. So now we know it's a step-up transformer. So it's going to deliver a higher voltage to that industry. Increases the voltage of an AC power supply from 110 volts to 220 volts. So that diagram is a step-up transformer. So it means the voltage in the primary coil is 110 volts, and it's been increased to 220 volts. The primary coil dissipates a power of 1.1 kilowatts. So if we say voltage times current, the power in the primary coil is 1.1 kilowatts. And the transformer has an efficiency of 100%. It means they want us to use that formula. If the number of turns in the primary coil is 400, so these turns here in the primary coil, we have got 400. How many turns are in the secondary coil? So if it's a step-up transformer, the answer that we find has to be more than 400. So since now you have all that information, you have got the voltage in the primary coil, which is 110 volts. You have got the voltage in the secondary coil, which is 220 volts. You have got the number of turns in the primary coil, which is 400, and you want to calculate the number of turns in the secondary coil. So you just say voltage in the secondary coil over voltage in the primary coil is equivalent to number of turns in the secondary coil over number of turns in the primary coil. So this is the relationship that we're going to use. Then you just substitute. The voltage in the secondary coil is 220 divided by the voltage in the primary coil is 110 volts, is equivalent to the number of turns in the secondary coil, which we want to calculate, divided by the number of turns in the primary coil, which is 400. So from there, what we're going to do is we're going to cross multiply, giving us number of turns in the secondary coil multiplied by 110. Let me just give myself more room to calculate. If we cross multiply there, we're going to have 110 multiplied by number of turns in the secondary coil is equivalent to, you get your calculator. Where is my calculator? Okay, it is. You get your calculator and you multiply 220 by 400. That will give you, is this 88,000? Yeah, this is 88,000. That will give you 88,000. Then you divide both sides by 100 over 100. That cancels your number of turns in the secondary coil. So we divide that. Oh, this is 110. So 110. So we divide this by divided by 110. You're going to get 800 turns. So the number of turns in the secondary coil has been calculated as 800 turns, which makes sense because now here we have got 800 turns. We're going to, there will be a higher voltage delivered. So this will be directly supplied to an industry or something like that. So interestingly enough, uh, uh, you just have to watch this video. Just watch it. It's going to make sense. Trust me. So now the question is, has come, which says, how much current flows in the primary coil? So how much current flows through the primary coil? So I told you here, we have got a voltage in the primary coil and current in the primary coil, meaning we have all the necessary information to answer this question very easily because we have got voltage in the primary coil and we've been given the power. See, the primary coil dissipates a power of 1.1 kilowatts. So let me actually just solve it here because we have all the information. So you use this formula and I'm going to write very big things so that you will see properly. You tell the examiner that power is voltage times current. The power that we've been given is 1.1 kilowatts. The standard SI unit for power is watts. So if you go on your prefix table, this kilo here is 10 to the power 3. So it's like you're multiplying 1.1 by 10 to the power 3 watts, which is like saying 1.1 multiplied by 1,000. 1.1 multiplied by 1,000 watts. So we're converting kilowatts to watts, so we multiply by 1,000. So it will be 1.1 multiplied by 1,000. We're going to get 1,100 watts. So this is what we use to calculate the power in the primary coil. So power, so here we just have to make current the subject of the formula. So how do we make current the subject of the formula? We actually divide both sides by voltage. That cancels, meaning current will be power over voltage. The power we've been given in kilowatts, we've converted it to watts. So that's 1,100 watts over the voltage in the primary coil, which has been given there. We even indicated it here, 110 volts. So divided by 110 volts. So I'm going to say 1,100 divided by 110. So the power that we're going to get, oh, sorry, the current. The current that we're going to get in the primary coil will be 10 amps. Just one formula. Power is voltage times current. Then you just make current the subject of the formula. So here we just go here and we say, let me quickly solve it here. So we say power is voltage times current. If you make current the subject of the formula, current will be power over voltage. We change 1.1 multiplied by 1,000. We got, what did we get? We got 1,100 watts. So the power is 1,100 and the voltage we had was 110, meaning our current in the primary coil, no wonder it's IP. So current in the primary coil will be 1,100 divided by 110. We're going to get an answer of 10 amps. So that's the current in the primary coil. So now we want to calculate the current in the secondary coil. And this machine, this transformer, is at 100% efficiency. So we're going to use our relationship. Let me actually write down our relationship down, which you have to know and memorize. Voltage in the secondary coil over voltage in the primary coil is equivalent to number of turns in the secondary coil over number of turns in the primary coil is equals to current in the primary coil over current in the secondary coil. So because they want current, we can use either one. We can use the voltage or we can use the number of turns. So just to be safe, let's use this relationship here, which is a voltage and current. So we're going to say voltage in the secondary coil over voltage in the primary coil is equivalent to number of turns of wants to find current now. So we're going to use that relationship is equivalent to current in the primary coil over current in the secondary coil. We substitute the voltage in the secondary coil was 220 volts divided by the voltage in the primary coil, which was 110, equivalent to, we just found the current in the primary coil, which is 110, and we now want to find the current in the secondary coil. So we cross multiply. This would be 220 multiplied by current in the secondary coil is equivalent to, if we multiply 110, so if we multiply 10 amps, this thing don't look alike, it's 10 amps. That was the current that we found. If we multiplied 10 amps, always lose my cursor. If we multiply 10 amps by 110, we're going to get 1,100. We divide both sides by 220 over 220. That cancels our current in the secondary coil. You get your calculator, you punch in 1,100 divided by 220. The current in the secondary coil, we're going to get 5 amps. So our current there would be 5 amps. So that's basically it with transformers and how you go about with your questions in terms of transformers. Okay, so again, as usual, make sure you just go through this video immediately I send it so that the information should be fresh in your brain, and just work through. So get a separate paper, you watch the video, you pause, you rewind, you pause, you rewind, you listen again, you pause, you rewind, until you understand these principles very clearly. Okay, so interesting diagram here. It's on electricity. So below shows 2 pairs of 3 ohm resistors connected to a 6-volt battery. Question 1 says you have to calculate in the circuit, or calculate the resistance in the circuit between M and N. So we want to calculate the resistance in the circuit between this point here, M, and that point there, N. So what I want you to notice is that the resistance between these 2 points there is actually the total resistance in the entire circuit. The resistance between these 2 points is actually the total resistance between these 2 points. And actually, these 2 resistors, the resistors above, are connected in series, and these resistors below are actually connected in series. And resistance connected in series, we can add it algebraically. So we can just say 3 ohms plus 3 ohms, that would be 6 ohms. So combined, total resistance for these two is 6 ohms, and total resistance for these two below is also 6 ohms. So we can say, we can convert this ray diagram to look like this. So that's our battery there. And this is the 2 points that we want to calculate the resistance. And these two resistors above and below are connected in series. So we can add them to just make one giant resistor, which is equivalent to, so this is point M and this is point N. Total voltage is 6.0 volts. So we can add them and say this is 6 ohms, and that is 6 ohms there. So the resistance between these 2 points is the total resistance. And now look at them, they are no longer connected in series. These two resistors, R1 and R2, are now connected. They are in parallel to each other. So resistance connected in parallel, if you want to find total resistance, it's actually the reciprocal of resistance, the upside down version. So you actually say R tot, which is the total resistance, will be 1 over R1 plus 1 over R2. That's the formula that we're going to use. Let me calculate it here. So R total is 1 over R1 plus 1 over R2. So the resistance between these 2 points is the total resistance in the circuit. What did we do? We converted the circuit. When I okay, these two are connected in series. So we're going to add 3 plus 3, 6. These two are also connected in series. So that's how we add resistance of a resistor that's connected in series. But with parallel, to find the total resistance, as you can see now, these two resistors are actually in parallel. So for a parallel connection, this is the formula we use. Total resistance is 1 over R1 plus 1 over R2. So R tot is equal to 1 over 6, which is R1, plus 1 over 6, which is R2. Then this is now a fraction. So the lowest common denominator will be 6. 6 divided by 6, so R dot. 6 divided by 6, it will be 1. Multiplied by 1, it will be 1 there. 6 divided by 6, it will be 1. Multiplied by 1, it will be 1. So 1 plus 1. So R tot will be 2 over 6. We make this a fraction over 1 and cross multiply. R tot multiplied by 6, because 6 times R tot, which is R tot total resistance. So it will be 6 R tot is equal to 1 multiplied by 2 to be 2. We divide both sides by 6. So our R total will be 1 over 3 if you want to divide that. You can also reduce it. You just say 1 divided by 3 and you get 0.3 ohms. So this is the total resistance throughout the circuit. So this is how you calculate this question. Then the question now says calculate current. So here we use Ohm's law. Ohm's law. So there is an Ohm's law formula which says resistance is voltage over current. And we want to find the current. So again, we make current the subject of the formula. Ri is equivalent to voltage. We divide both sides by R. That cancels. Our current will be equivalent to voltage over resistance. The voltage is directly on the circuit diagram at the battery here, 6 ohms. That's the voltage that we're going to use. So we just say 6 ohms or 6 volts, sorry, 6 volts. divided by the total resistance. No wonder it was very, very important for me to tell you that the resistance between these 2 points is actually the total resistance of the circuit. So you can actually divide this by the total resistance, which was 3 ohms. So if you divide that, the current that we're going to get will be this is 0.3, sorry. This is 0.3. So it will be 6 divided by 0.3. You get your calculator and punch 6 divided by 0.3. You are going to get a current of 20 amps. So that's our current, 20 amps. Then the question proceeds. The question proceeds. This is the last part of the question. The question proceeds and says, calculate the power developed in the battery. Again, power is equivalent to voltage times current. The voltage was given as 6 volts multiplied by the current that we just calculated, 20. You go on your calculator, you punch 6 multiplied by 20, you're going to get a power of 120 watts. So this marks the end of our class today. The next time that we do physics, I'm going to first teach radioactivity. This is usually the last question. So I'm going to teach radioactivity in detail. Then we're going to try to attempt this question. So when I send you the video, I want you to just start with the ray diagram on light. You know, you fast forward, you rewind, you get a book or a plain paper, you solve, etc. You solve, you rewind, you study, you go to YouTube, you research. Research is very important in your academics. Don't just expect one person to teach you. You know, use Google as a research. Go on YouTube, research, research, research. After doing your ray diagram questions, you research on transformers, you answer this question, you go on YouTube, you research, you study more, then you go on electricity again, you research, you study, you research, you study. And you know, that's how we learn. No one is actually born a genius. Well, some are academically gifted. But for people like me, you know, who are not academically gifted, we have to study. We have to go there, dedicate ourselves to our education. We sit down for hours upon hours and just study. And you know, school gets actually very, very interesting and very difficult. Some of us, you know, being at Ridgeway campus is actually very intense. Every Friday, every Saturday, if I'm having a test or an exam or around the corner, I would actually go into the library around 10 hours somewhere there, and I would leave at 21. Because, you know, I am not naturally gifted in any way. I have to put in the effort for me to produce results. So that's how school is. Don't say, I'm running out of time, I won't be able to answer or understand this. You just have to study and focus. You have that power and ability within yourself to have that genius brain also. So a genius is not born, or an intelligent brain is not born. An intelligent brain is actually created through consistent hard work. So on that note, I'm going to end our recording, and I'll see you tomorrow. See you tomorrow.